Welcome back. Today we're going to talk about synthetic division, and synthetic division is really truly a nice shortcut to divide polynomials. And so there is a little bit of a trick to it. You're going to be dividing a polynomial, in this case something with a power of 3 all the way down to the constant, by x minus k. So this can only work with x to the first minus k. So it doesn't work with an x squared or an x cubed as what we're dividing by. So it'll only work with an x minus k. But if we have that situation, this is a really quick shortcut for doing that. Here's how we're going to set it up. This is the pattern that we're going to use. We're going to put k on the outside, and then we're going to draw our box like this. And what we're going to put in here is the coefficients of our dividend. So in this case, it would be like a, b, c, d. And these are, as we did in polynomial division, you have to have all of them. So if it's an x to the third term and there happens to be no x squared term, you're going to have to put in a 0. Coefficients of the dividend, as opposed to the divisor, which is what we're dividing by. And I'm going to put must fill all places. So you may have a 0x squared. So you might have 0. So you might have a 0, like a 0x squared term, or you might have 0 as the constant on the end. And the pattern that we're going to use looks like this. So we're going to bring down a, and then we're going to multiply k times a here, and we'll bring this down, and whatever goes here, so I got to draw my circles, and then that's going to be multiplied to get what goes here, and then we add to bring it down. Get something here, multiply it. Get something here, add to bring it down. Okay, so the pattern is vertically, we're going to add the terms. And then diagonal, so anywhere you see like a diagonal line here, like we're going across, we're multiplying by k. And you're going to see how it works, trust me. But we bring down a, so in this box would go a. When we add a plus the nothing that's here, we get a. So then in this circle here, we're going to have k times a. So like here would be b plus ka. And then we'd multiply that times k again. So you're going to see how this works as we get into an example here. But just know that it's adding vertically, multiply by k, the constant over here. Add vertically, multiply by k, the constant over here. Another thing to note is this is x minus k, and then k is over here. Well, x minus k, the purpose of this is to find zeros, and so we get the k by saying it's a 0 solution. So this is going to be a solution, and so when we add k to both sides, that's why we put k here, just so you know. So what is the takeaway from that? You're going to do the opposite of whatever is in here. So you've got like minus k here, so you put positive k out here. If you had x plus k, you would use minus k out front. Okay, so you're going to use the opposite of whatever's in the parentheses. You got a minus k, you're going to use k. You got a plus k, you're going to use a minus k. Okay, so that's kind of how this works. Let's look at an example. I think that's the easiest way to see how it works. So let's look at an example of synthetic division here. I've got an x to the fourth minus 10x squared minus 2x plus 4, and I'm going to be dividing by x plus 3. So let's just get this set up. When I set up my box here, I'm going to put inside of it my coefficients. Well, notice I've got an x to the fourth term here, and so that's what I'm going to start with. So my coefficient out front of that one is a 1, and now I notice my next one is a 2. Well, I have to have an x to the third term, and so since I don't have one, I've got to put a 0 in as a placeholder. I've got to go all the way down the line in terms of the degrees of the exponents. So then my x squared term is going to look like a minus 10. My x term is going to be a minus 2. And then my constant is a 4. So here is my setup. What goes out here? Well, this is x minus k. Well, my k, in this case, it's got to be the opposite of positive 3. So this would really be like x minus a negative 3. So my negative 3 is what's going to go out front here. If you can't remember the whole math part behind it, it's the opposite of whatever I'm doing there. So if I've got a plus 3, it's a minus 3. All right, so now, how does the process of synthetic division work? Well, I have to get it started. So I'm going to bring down my 1. And so as I bring down my 1, then I'm going to multiply negative 3 times 1. So negative 3 is going to go here. Okay? Then I'm going to add. So 0 plus negative 3 would be negative 3. And then I'm going to multiply negative 3 times negative 3, which will give me 9. So I'm multiplying there. Then I'm going to add. So this is a minus 1. And I'm going to multiply negative 3 times negative 1. So that's going to be 3. Then I add to get a 1. Once again, I'm going to multiply negative 3 times 1. So that's minus 3. And when I add, I get a 1. Well, what does this all mean? Here's something that we need to take note of. The last one is the remainder. Okay, so the last column is the remainder. And so up from there, it starts from the right side. So from the right side, it's going, constant, x term, x squared, x to the third. And so my first one is the coefficient of 1 degree less than the original. So I started with an x to the fourth term, so this represents 1x to the third. Okay, because my original started with an x to the fourth, my first column is 1x to the third, and then from there it just flows down. So 1x to the third minus 3x squared minus 1x plus 1 plus 1 over, and my divisor is x plus 3, so 1 over x plus 3. That's my remainder there. And so my answer of x to the fourth minus 10x squared minus 2x plus 4 when I divide it by x plus 3 is x to the third minus 3x squared minus 1x plus 1 over x plus 3. This is my answer. So that is what you would write down when you use synthetic division to divide. Nice little shortcut, don't have to worry about adding, it takes up much less space. So I'm adding this way, multiplying across. Let's do another example. So we're going to start with the factor theorem. The factor theorem talks about when you divide the polynomials using synthetic division or regular division, if you have a remainder of 0, then it's an even division. That means it's a factor. Okay, and so there's nothing extra on the end. It would just be an even division. And so when we look at a problem, what they want us to do is show that these two are factors of this big old honking thing here. Meaning, when we divide, the remainder will be 0. Well, think about what that means. All this time that we've been factoring expressions and trying to find zeros, we're factoring it into all these little pieces. Well, really, to factor means to divide out, because we could always FOIL back in. Well, if I'm showing that these are factors, these are zeros. This is the process of finding zeros. So zeros come from this. Because if I had x plus 3 equal to 0, I could say, oh, hey, look at that. X plus 3 is equal to 0, so x is equal to minus 3. So zeros come from the factors. And so this process of breaking this down, dividing it using synthetic division or whatever, and breaking it down into smaller expressions, this is great. So let's do this. Let's show this one first. So because it's a minus 2, I'm putting 2 on the outside. And inside, I'm going to put 2, 7, minus 4, minus 27, and minus 18. Okay, because these are all my coefficients here. So as I'm going across, we are going to show that this is indeed a factor. Okay, so let's go. I'm bringing down my 2. 2 times 2 is 4. 7 plus 4 is 11. Okay, so I am multiplying and then adding. So I'm going to multiply to get 22. Then I'm going to add to get 18. Okay, then I'm going to multiply here to get 2 times 18 is 36. When I add, that's going to give me 9. I'm going to multiply across again. I should have extended this line here. Multiply across here again to get 18. And so negative 18 plus 18 is 0. Okay? And so as I'm looking at this, I bring down my 2. Multiply 2 times 2 to get 4. 7 plus 4 is 11. 2 times 11 would be 22. 22 plus negative 4 would be 18. Then I multiply 2 times 18 to get 36. Negative 27 plus 36 would be 9. And then I multiply 2 times 9 to get 18. Add vertically, multiply diagonally. Well, this is my remainder. So that means x minus 2 is a factor. Well, what we can do is now we know that this polynomial evenly divides by x minus 2. And so what we're going to do is we're going to use the answer here. So this is going to be 2 is 1 less degree than my x to the 4th. So this will be 2x to the 3rd plus 11x squared plus 18 plus 9. Check this out. This polynomial now is equal to my original 2x to the 4th plus 7x cubed minus 4x squared minus 27x plus 18 or minus 18 equals what I got times x minus 2. Well, what I'm going to do is I'm now going to take out an x plus 3. Well, I don't have to start with my original. I can go to this because this is part of my expression, but it's just times x minus 2 would give me my original. So I'm going to use this now in my synthetic division. So I'm going to take x plus 3, so I'm going to put minus 3 on the outside, draw my box, use my coefficients, 2, 11, 18, and 9. I'm doing less work. I have one less column because I've already shown that I can take out an x minus 2. Now I'm going to take out an x plus 3. So here we go. Bringing down the 2. Negative 3 times 2 would be negative 6. When I add, I get 5. I'm going to multiply across. Negative 3 times 5 would be negative 15. When I add, I get 3. So 18 plus negative 15 is 3. Multiply again, I get negative 9, so I get a 0. This is my remainder. Okay, so x plus 3 is a factor of my polynomial. And so what does this mean for us? When I divided, remember this was 2x to the 3rd. So this is going to be now 2x squared plus 5x plus 3. And what I was dividing by, so that means my x plus 3 goes here and my x minus 2 goes here. Well, this whole thing, because I divided now, remember I'm dividing. I divided the original by x minus 2, so my original divided by x minus 2 gave me this. When I divided it by x plus 3, I got this here. I got this 2x squared plus 5x plus 3. So this whole thing is now equal to my original. Because if I multiplied back everything that I divided out, I'd get my original expression. Okay? And so what happens is, this is now something that I could factor. And I could find all of the zeros. You see how this works? And so as I'm doing this, I'm getting closer to breaking it down. I broke down this humongous expression by using synthetic division into a quadratic and two expressions that I already know how to figure out if they're zero. Okay? And so that's the gist of synthetic division. We're breaking down expressions to be able to find the zeros. Okay? Thanks for watching, guys. Please write down any questions that you have, and we'll go through them tomorrow in class. Appreciate you watching, and we'll see you next time.